Welcome back to the Anatomy of a Riflescope series. In this video, we're going to be running through a component that is extremely critical to the way that a riflescope operates, but is completely hidden within the body tube. Now, you may think of a riflescope as just a body tube holding a bunch of lenses and some turrets, but there's actually another tube that sits inside the body tube that has so many jobs, including flipping your image around so you see it the right way up, holding your reticle, holding the zoom lenses that control your zoom in and out, and physically moving to compensate for a shot every time you dial your turrets. I'm talking about the Erector Tube, and I have a couple of them right here. The Erector Tube is almost like a little riflescope in itself. It's quite compact, but if you look at the expanded view of everything that sits inside it on this 5-25 Titan model in front of me here, you can see that it holds a lot of smaller components. In the front, if you have a first focal plane riflescope, will be the reticle. If you have a second focal plane riflescope, this will be at the very back of the Erector Tube in your second focal plane. We'll get in a later video to the discussion of what a reticle actually is, how it's made, and the different types of reticles and reticle illumination that you get, but that's a discussion for a totally different video. Moving back, you'll notice a bunch of spiraling slots on the outside of the tube. This is actually your zoom mechanism, and it's quite interesting. When you turn your magnification ring, there's actually a pin that sticks down into a slot on this outer sleeve of the Erector Tube, and as this outer sleeve turns, it presses these guide pins forward and backward, which in turn moves your zoom lenses forward and backward in a very, very controlled manner. The tolerance of each of these components is extremely important. If these slots and the guide pins and the zoom cells are not machined correctly and there's too much play or too little play, then it can affect the location and the orientation of these zoom lenses at any given time. And as we discussed in the first lens video, the position of the lenses is just as important as the actual quality of the lenses themselves. If there's any play between the zoom cells and the guide tube that holds them when they move forward and backward, this can also cause a perceived shift between the reticle and the image. And we test for this on every single scope before we send them out. The riflescope can be placed in a collimator and the reticle aligned with the reticle on the collimator, and we can dial the zoom in and out and see if there's any shift whatsoever on the reticle. Moving back a little more, it gets even more interesting. Here we find a 2-axis gimbal that actually holds the rear of the Erector Tube in a perfect location while allowing the front to move up, down, left and right. And this is how your riflescope actually adjusts for elevation and windage. The rear will be held in place, and in the front your turrets press against the Erector Tube, and from the opposite direction an erector spring will press back, and this allows your Erector Tube to move very precisely and compensate for your shots. The clearance between the Erector Tube and the body tube is what determines how much elevation and windage travel you will have, and that is why, generally speaking, a larger body tube does mean that you will have more elevation travel. I say generally speaking because the size of the Erector Tube also has a part to play in this, but let's just dispel one myth right away. A bigger body tube does not mean better light transmission or a brighter image. It just means there's more space for the Erector Tube. It's the Erector Tube itself that determines the optical performance of your riflescope. So what about prismatic scopes? I suppose you're wondering how an Erector Tube would fit into something like this. This is one of our immersive series prismatic riflescopes. Well, clearly it won't fit, but let me show you how the prism works. This is a model of a 14x50 immersive series riflescope, and this right here is the prism. This essentially replaces the whole Erector Tube. And the way that this prism works is it actually does the same job as the Erector Tube does in terms of correcting the image, flipping it from upside down to the right way around, and it does so by bouncing the light off the inside of the prism before it comes out the other side. Obviously the benefit is this is really nice and compact, However, the downside is that we don't have any zoom cells in here that can move forward and backwards. So we lose the ability to have a variable power optic on the prismatic scope. Aside from zoom though, it still does everything that a normal Erector Tube does. It allows for movement on the gimbal, so you can dial elevation and windage. It flips the image around, erecting the image, and it holds a reticle in place. In the next couple episodes, we'll be discussing a few more components that work hand in hand with the Erector Tube. We'll talk about the turrets, we'll talk about the Erector spring, and we'll talk about reticles, different types of reticles that you get, and different ways that those reticles can be illuminated. Make sure to follow along on social media and on our website.